Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, guys, we're going to be talking about geothermal and nuclear energy. So put down today's title, it's going to be Geothermal and Nuclear Energy. And before we get going, guys, make sure you hit the like and subscribe button to keep my channel going and keep my content as free as possible. Alright, so guys, what exactly is geothermal energy? Let's discuss it. Okay, so what exactly is geothermal energy? Well, let's look at the following diagram. So over here, guys, we've got a pipe, and here this is the ground. Yes, so I'm just going to shade that in as a ground, guys. Here's the ground, making it clear it's the ground. And what happens is they pump water into it, so into this pipe over here. So let's go water going into it over here. The water goes down, goes down. But underground, guys, there are hot rocks. So these are hot rocks over here. So these are hot rocks over there. These are hot rocks over here. The hot rocks will produce heat and it will heat up the water that comes in. So the water that comes in, guys, over here, there's the water. It gets heated up and it turns into steam. So it exits right now and it's turned into steam. Highly pressurized steam. So this is now the steam. The steam that comes out will then push through the turbine, causing them to spin. And as the turbine spins, so this little wheel over here is the turbine over here. And as the turbine spins, it connects to the generator and electricity is produced, guys. So over here, the generator generates electricity. So electricity is produced over here. Electricity is produced over here. Right, so that's geothermal energy. So using the energy from the hot rocks underground, to drive turbines to generate electricity, guys. A really clever method of generating electricity. So make sure you understand it. They pump the water down. The hot rocks underground are going to heat up the water, turning it to steam. It's highly pressurized. It will cause the turbine to spin, connect it to the generator, which will generate electricity, guys. And it's over here. Fantastic stuff. Geothermal energy. The advantages of geothermal energy are the following. Number one, it's renewable. You can use it again and again and it will never run out. Second advantage, there is no carbon dioxide being produced. No carbon dioxide is being produced here, so that's great for the environment. Disadvantage, it's only certain locations, so you can't build it everywhere. It's only certain locations around the world that you can actually have this infrastructure. It won't work everywhere, so certain locations only. Another disadvantage is drilling underground could trigger earthquakes. So obviously you're going to be drilling underground, but this can actually cause earthquakes to occur, and obviously you're going to disrupt the stability underneath you. So these are the advantages and disadvantages of geothermal energy. Right, so instead of geothermal energy, guys, we can also talk about nuclear energy. Okay, so nuclear energy. Right, I'm going to briefly discuss it right now, but there's a whole chapter in the GCSE which is dedicated to the nuclear energy topic. If you click on my playlists, you'll be able to find it, guys. It's about 7 or 8 videos. So following this, if you still want more information on nuclear energy, you look at that playlist. So what exactly is nuclear energy? Well, nuclear energy is the following. It is the energy obtained from when you split an atom. It's the energy obtained from when you split an atom and using that energy to generate electricity. So let's say, for example, over here that we've got an atom over here. Hopefully you've seen this in chemistry. It's a stable nucleus right now. If you cause it to split, which is called fission, that's why you have the term fission. It means the splitting of a nuclei or nucleus over here. So you take the stable nucleus and you cause it to split. What will happen is it will obviously, let's say a bit of it flips off there, another bit goes down here. But you also get energy being released in the form of heat, guys. So the energy is also released here in the form of heat. So in the form of heat. We're going to take this energy, which is released from when you split the nucleus up, and we're going to use that to generate electricity. Hopefully this makes sense. We're going to take a stable nucleus and we're going to cause it to split. When it splits, it will release energy. When it releases the energy, we're going to take the energy to produce electricity. And that's how nuclear energy works, guys. So when you see a nuclear power plant, that is the basic principle behind it. Obviously, if you want more information, check my other playlists out and all those other videos for a nuclear energy topic. Right, from here you might not be able to visualize how it's connected to the turbine or generator, so I've got the following diagram to help you. Okay, so as you can see, we've got the nuclear fuel over here and it will produce the energy. Good, the energy comes out from the nuclear fuel and that will cause the water inside this boiler over here to heat up and turn into steam. So then the steam comes over here. So this is my steam. The steam then goes through the turbine. As it goes through the turbine, it causes it to spin. And as the turbine spins, it's connected to the generator, which will generate electricity over here. And that's a very simple model of how a nuclear power station works. But obviously make sure you understand that it's the nuclei which is splitting in the fission process which produces that energy. Make sure you understand that. Okay, right, so what about the advantages and disadvantages of nuclear energy? Okay, so advantages of nuclear energy. Number one, there is no CO2 emission. There is no CO2 emission. No carbon dioxide is emitted in the whole process. Second advantage is, if I gave you 1 kilogram of nuclear fuel, it produces 1,000,000 more times energy than 1 kilogram of coal. So if I gave you 1 kilogram of nuclear fuel, it produces 1,000,000 more times energy than 1 kilogram of coal. That's the second advantage. Disadvantage is it's non-renewable. Yeah, a lot of people think it's renewable. No, it's not. It's non-renewable because you only have a certain amount of nuclear fuel available. So there's a finite amount of the nuclear fuel available, and the nuclear fuels are uranium and plutonium. Second disadvantage is going to be if there is an accident, large amounts of nuclear waste can be released into the environment. So if there's an accident, there's a large amount of nuclear waste that can be released into the environment. Obviously, we have those disasters such as Fukushima and Chernobyl, which obviously released a dangerous amount of radiation into the environment. The next disadvantage is going to be the following. It is difficult to dispose of. It is difficult to dispose of. Nuclear waste remains radioactive for a long time, so it's very difficult to dispose of that nuclear waste, guys. And that is our last disadvantage. Okay, so we're done for another session. Let's have a recap right from the top. Today's title was Geothermal and Nuclear Energy, and we started off with the following. I had a diagram down to explain geothermal energy. We have a pipe, it's connected underground. We pump water in, and the hot rocks underground heat up that water, causing it to turn into pressurized steam. That steam then turns the turbines, which then connects to the generator, and electricity is produced. And that is what geothermal energy is. It's using the energy from hot rocks to generate electricity. The advantages of geothermal energy are the following. Advantages, it's renewable, no CO2 being produced. Disadvantages, certain locations only, drilling underground could also trigger earthquakes. And then we moved on to nuclear energy. Nuclear energy, guys, is the energy obtained from the fission splitting of nuclei to generate electricity. And as you can see, I've got the stable nucleus here. If you make it split, it will produce energy, and we're going to use the energy to generate the electricity that we need. As you can see over here, we've got nuclear fuel, and as the nuclear fuel produces the energy, it heats up the water. That water then turns into steam. That steam is then used to push and spin a turbine, which is connected to a generator, which generates electricity. Then last of all, I outlined the advantages and disadvantages of nuclear energy. Number one, there's no CO2 emission. Number two, for 1 kilogram of nuclear fuel, it produces 1,000,000 more times energy than 1 kilogram of coal. Disadvantages, non-renewable, finite amount of nuclear fuel available, so it's a non-renewable. If there's an accident, guys, it can release a large amount of nuclear radiation into the environment. And last of all, it's difficult to dispose of the nuclear waste. It's very difficult to dispose of the nuclear waste. And that's it for another session of CeerazzleDazzlePhysics. Make sure you hit the like, subscribe button to keep my channel going, and good luck in your studies. Ciao, ciao, and goodbye.